From radians to degrees. Very good. 180 over pi. Radians to degrees. I'm skipping around. The next couple, I'm on 25.
Oh.
Can't you guys keep up with what's going on in my brain?
No.
Drink more coffee, you'll be fine. You have $1?
Actually.
27, negative 9 pi over 4. Multiply that by 180 over pi. So pi's drop. And then 4 goes into 180. What is that? 45. So 9 times 45 is some number that I don't know off the top of my head. You put a negative in front of it. What is it? 455. Oh, 405. You all right? Positive and negative coterminal angles. 29. So if you're doing positive and negative coterminal angles, that means that you have to find an angle in terms of radians, in this case, that are within one ringy-dingy, one revolution plus or minus. But first thing we always do is check to see, is this beyond, bless you, is this beyond one revolution? How do we know that? Well, we know that by saying 13 divided by 4 is? So it's negative 3 1/4 pi. So this was the time that using mixed numbers was helpful. Since this is beyond one revolution, negative, I have to bring it within one revolution negative, and then move it out positive one revolution. So what I have to do here to do that is I'm going to add 2 pi. So my one would be at negative 1 1/4 pi, otherwise known as negative 5 pi over 4. And then I do that again and add another 2, which would get me, what, 3 pi over 4. There's your positive and your negative. If you want to use this instead of saying 2 pi, and you want to realize that this is still 13 pi over 4, you're just adding 8 pi over 4. Same basic principle by keeping the common denominator. This is honestly probably the only time that mixed numbers are helpful. Really. Otherwise, they're just... and that's quite literally what they're called. Hi, Sawyer. How are you?
I'm the final.
There's a final? Sorry. Sorry, I didn't mean to break your train of thought.
Are you gonna have is there a chance you'll have a simplified form and then unsimplified form?
What do you mean?
If it's
like 10 pi over 8 and 5 pi over 4?
Yeah.
And then I make sure that if I like a trick question like that?
Yeah.
No, I wouldn't do that to you. No, that's stupid. I mean, it's something I would do, but it's not something I would do. But you know what? That makes sense. It totally makes sense. It's something I would do, but it's not something I would do.
It sounds like something
you would do. It's not something
Yeah, that's kind of. It sounds more vague when I do it the other way. It's kind of fun. Yeah, no, I wouldn't do that. I wouldn't have like 2 answers and you have to figure out which one is the more simplified version of the other. I like coffee. It's delicious. Made a good blend today. Toasted Southern Pecan. You guys ever had that one flavored from Cameroon's? Shut up, Maggie. Toasted Southern Pecan. It's a great flavor. I mix it with a little bit of Folgers so it's not all right there. 4 scoops of Folgers, 3 scoops of that. Just regular little scoopers. The ones that come in the container. That's why I make some around. For what? Well, we didn't do statistical stuff in 7. So there's that. Exponent rules. Really, chapter 7 is exponent rules. Solving equations with exponents. Arc length, or area of a sector. So you've got theta is pi over 2, and your radius is 12. Now, I'm pretty sure and certain that the formula was 1/2 pi r, or I'm sorry, no pi, it's just theta r squared. So I have to do 1/2 of pi over 2 times 144, which means this is what, 4 goes into that, 26, so is it 26 pi? 36 pi, math is hard. Shut up. I'm trying to do it in my head. Arc length, 35. Arc length was just theta r. So 7 pi over 12 times 15. Bless you. Pi was 5, 5, and 3. So 4. 35 pi over 4. $37 is 1. Remember how to trig? So trig, gotta get triggy with it. Hey, that might have been important at some point in time in one of our lives or somewhere around there. I don't know. It may or may not have come up once or twice. Yeah, I've only seen it like one day. We only used it once. Same thing with these. And those had no bearing upon anything we did in trig, did they? They were unimportant, to say the least. So this was what, 1 root 3, 2, 1, 1, root 2. So find the value of the trig function indicated. So tangent of theta. Tangent, I think that's the TOA. Tangents are oranges and apricots. I don't think so. I haven't had an apricot in a long time. I can say that. I had an orange and an apple for lunch today. So yeah, of course. Better than eating big bags of chips. So why was I able to figure this out so quickly and efficiently? So I had to do this crazy thing called math to figure out my missing side length. Now, if I didn't recognize that I had a 14 and a 14 root 2, could I have used this crazy little thing called Pythagorean theorem at some point in time to figure out what this is? I don't know. You may or may not have seen that at some point in time in your lives. I'm pretty sure I didn't teach you that, but I'm sure somebody somewhere at some point in time mentioned what that was. He tried to, the whole Pythagorean theorem. Yeah, he's bad at that. Yeah, so if you forgot how to do it, you just have your a squared b squared equals c squared. One thing to remind you guys of when you have your calculators, if you are squaring something with a radical, you have to put it in parentheses. So anytime you square something that has a radical around it with your calculator, you have to throw parentheses around it. That will be one of those common things that will be one of the multiple choice parts that people do incorrectly. Just an FYI. So that's how you're able to figure out the opposite side. We're trying to figure out what the tangent of theta is. So tangent is opposite over adjacent, so that's where you get 1. Uh-oh, cotangent. Cotangent is the reciprocal trig function of tangent. So so if tangent is apples and oranges, no, oranges and apples, cotangent would be apricots and orangutans. Sounds great. Have you ever seen an orangutan eat an apricot? I haven't either. So it would be 8 over 6, otherwise known as, now Sawyer, this is kind of the point where you're getting at, oh, the cotangent could be 8 over 6. Yeah, but means it's 4 thirds. Hey, at least you're thinking ahead. Okay. I'm not quite sure, but so there's that. Hey, guess what? Your final is the day after a 3-day weekend. Yes. Hey, it's the last year you gotta deal with it like that though, unless we have a lot of snow. For one summer, get over it. It's a week. It's a week. It's a week. It's a week. I will give up. I'll give up that big time. It's a week. It's a week. If you're happy and you know it, clap your hands. All right, solve the triangle. What do you do?
It's only 3 miles.
Yep. Start with angles or whatever. You get what? Sure. Hey, top tip. Remember, always use the given information in any diagram to solve everything else. Because if you use, let's say you accidentally said this was 42 because you brain farted and thought that angles in the triangle would be, the 2 other angles would be 100. That's all the time. And if you use that 42, will you be right with either of the other sides? That's why you always try to reuse your givens in these types of problems because you run less of a risk of screwing something else up. So if I use tangent 58 is your opposite over adjacent, and then cosine 58 is your adjacent over your hypotenuse. Now, do you guys remember how to verify what mode your calculator is in? You press correct. You press the button that says mode. Now, reminder, you want when you are doing trig, when you're doing trig in the calculator, you need to be in degrees. That means for when you're doing trig in terms of solving for triangles and law of sines, law of cosines and stuff. But if you wanted to look at it on a graph, you'd have to be in radians. So if you ever have to do anything with a graph, and you want to verify something, you got to go to radians, and then it's not going to say that you're at like pi over 4 or anything like that, but you'll get decimal equivalencies, and you have to, mess around with it. It just doesn't look as clean otherwise. Right? Just a little FYI. I want to say that just because we never graphed with these calculators, but if you ever did need to look at a graph, you'd have to switch it into radian mode to do so. Not to say that there are graphs on there, not to say that you have to be able to graph something, but in case there is, I thought it'd be fair just to say, hey, don't forget. Okay. And then obviously, I'm guessing you guys know how to solve that.
favorite.
So right.
Oh my gosh, there was a copy of Rolling Stone, and he just totally looked like an old lady. Like, he was in the Queen. This is Paul McCartney.
Queen Mall. Oh, absolutely. So I want to solve for my opposite here, just to make sure that we're not making a dumb mistake, because we don't want to do that.
We don't do that.
So I would do 8.7 times the tangent of 58, and I'd hit enter, and that would give me that one. That would give me my opposite. Mackie, I am proud of you for remembering something that I said that was stupid. I know, that's weird. Write that down. What are you laughing at? Probably, yeah, that's what you said. So we should make a bet. How many years will have to go by before that tree is taller than the building? That one right there. Well, the one that I can see the closest to us. No, this tree that's closest to us. I'd say about 6 years. 7 years? Those are quick growing trees.
And I said, one by the lake.
The closest tree to me.
What was it by?
I want a tree.
Like 7 years ago.
At least 7. I mean, that will always be right.
It's like the if you guys ever go out north on First Street, the big house that got built out there at the horse barn. That way. Going out on First Street, they lined their front driveway with all the trees. Give that 10 years, that front drive's gonna look gorgeous with all those big tall trees. When it goes through, it's gonna look. It's a rough life, Dave. It's kind of rough. Don't, doesn't everybody? You mean you don't? You don't? I just bring my RV over for the people to sleep in my driveway. It's a joke because they can't, because I got a camper and it's plugged in. Anyway, back to math. Cosecant destroyed. 1 little, 2 little, 3 little. So, hey, guess what? Chicken butt. No, I'm kidding. My kid says that.
You gotta think it's not funny now.
I have absolutely no idea what you're talking about.
So the person says, guess what? And you go, get what? Chicken. And you go, put it in the cup. And the other person will find, go around the corner and lick it up.
So is this just what goes on in your head?
No. In my last 2 grades, I was talking to each other.
That's a quote of the day.
Right now. Like that, and then there's like dancing. Oh my god. So like about thinking about everything. It's so fun. I'm really excited about my last 2 days. I can't read that.
Anyway, so here's a nice dead giveaway. What do you think the reference angle is going to be? Why do you think it's 45? Because there's a 5 in it. So that's got to be 45 degrees. So in quadrant 4, cosecant, the reciprocal of what trig function? Sine. So sine of 45 would be root 2 over 2, but cosecant would just be. Now remember what's going on. Cosecant, you've got your negative 1 and 1. Here's your root 2. Cosecant would then be just negative root 2. Sorry, this would be negative here because this is all negative. This would be just negative root 2. Remember, when you spin it, just plot your triangle real quick, get your reference spot, and go. Use the given point of the terminal side of angle theta to find the value of the trig function as indicated. That would be number 45. I hate to get ahead of you, but sometimes I do. Well, the rest of them are just like this. So if terminal side of theta lies upon here, so if the cosine I'm going to come up from theta, so we went negative 2 root 3. Hey, that makes my hypotenuse what? It'd be 4, yes. Because that means that theta is at a 60 degree, because of the way the pattern works. It winds up being a 30, 60, 90 triangle there. Obviously, you're just using Pythagorean theorem to get your radius. So if they're asking to figure out what cosine is, your cosine here, 60 with that would be what? Negative 2/4 would be negative 1/2. Right. That's MRT. Uh-oh. I'm afraid. Solving triangles that are not right triangles, which means we have to make a decision. Law of sines, law of cosines. So, will you use law of sines or law of cosines to solve the rest of this triangle? Law of sines, yes. You will use law of sines. The reason why you use law of sines is because you have an angle and a side opposite. Okay? That's when you choose to use law of sines. Now, do I have to worry about the ambiguous case? It is a no. The reason why it's a no is because there's already a secondary angle there. I don't have to worry about finding the second angle. So now all I have to do is figure out the third angle to start. So this is, now bear with me here. Was it 86? I believe we get 20 for angle A. Now I just use law of sines to figure out the rest. So I've got the sine of 94 is to 35 as the sine of 66 is to side C. Sine of 94 is to 35 as the sine of 20 is to little a. And when we did this stuff, it was just a lot of cross multiplying and solving. It wasn't really all that difficult. It was just a matter of setting it up. So when I do this one, I would get little c would be equal to 35 sine of 66 over sine of 94. And then little a mirrors the exact same set. The trick for that secondary triangle, if that ever does occur, is when you were only given angle side side. if you are given angle side side for law of sines style problem, when you find your second angle, that's when we would check for that supplement to see if there was enough degrees with the original angle to create a second triangle. It was a shortcut way as opposed to what we did, what the textbook would always show about all those different formats you'd have to try out. Okay? I don't think either one of these on here did a secondary triangle. The law of sines, law of cosine stuff was in chapter 13. I believe it was section 13.5. Yeah, 13.5. It was confident. So, for example, if I look at one like this, let's use a really simple one. So, if I had to solve the triangle like this, I've got A is 20, or angle A is 20, little a is 10, little c is 11. So what I would do is just real quick, draw the triangle out. Yeah, this is going to be, I'm showing an example of what happens, of how you would be able to tell if you're going to have a secondary triangle. This one is forcing you to find angle C to start with. Everybody okay with that? So we set it up, we've got sine of 20 is to 10, as the sine of C is to 11. Which means I just move the 11 in front here, and I press buttons. So when I press buttons, I'm going to get, it's 11 sine of 20 divided by 10. Second sine of my answer. And C is giving me an angle of 22.1. You okay with that? So the first angle that I have for C is 22.1. So what I do is I go and figure out its supplement. 180 minus 22.1. And I get 157.9. Remember, we call that C prime. And all I'm doing here is I start with that, and then I go back and I look at what my original angle was. Our original angle is A, which is 20. So if I put A and I add that to the supplement, I get 177.9. Is there enough degrees left to make a second triangle? Yeah. That's what it meant to check the ambiguous case. Ooh, if you only had a case. Would have done. So that's what you would do in order to check to see if you had to come up with a secondary angle. You only had to do that if the case was angle side side. Okay? And then everything else falls into place the same way. Law of cosines. The next one for law of cosine problems where it's just a matter of just start with which angle first. Remember? Say it. Biggest. You're saying biggest. Oh, when you do law of cosine, yes, ma'am. Yes, ma'am. There, grab the little triangle. Always start with the largest angle for law of cosine. So on 49, I'd say 29 squared. When you do one like 49, always find the largest angle first for law of cosines problems because that's kind of how it works. Because if you do it that way, you won't have to worry about the ambiguous case. Again, it's just a bunch of buttons to start out with law of cosines. After you get the first angle, then just use law of sines because it's quick. Remember, area of that triangle is 1/2 side angle side. Let's use side angle side with the angle is the sine of the angle. 51. Ooh, graphing. What we haven't even done the equations yet. Graphing. 2 tangent theta over 2 plus 7 pi over 6 minus 1. In order to do this, I got to get that the b value outside of the out of the parentheses. So I got to factor out a half. Okay. So I get 2 tangent 1/2 theta. Now, 1/2 times what equals 7/6? Basically, look at it this way. 2 times what is 6? 7. It has to be 7 pi. Because remember, when you distribute back in, it should equal what's in the parentheses. Now you have your a value, your b value, your h value, and your k value. If you know this, then you can figure out where your asymptotes go. Now, the period of tangent, pi over b. So in this case, this one has a period of 2 pi. If it has 2 pi, that means your asymptotes will be set at pi, plus or minus pi. And then go on from there. Oh, I didn't realize I had just two changes in cosine. Oops, that's my fault. All right, well, we'll finish out trig and keep going on the rest of it. Trig's pretty important. We'll keep going back to trig too. Sequences in series, man, that's just a lot of formulas. Really all it is. It's formula. And guess what? There's another formula. And then a formula. And a formula. And guess what? There are more formulas. Fun times. Oh, yes, indeed. It's fun times.